Okay, I'm going to pick on someone at random. That random person's Bailey. Bailey, what's the derivative of 2y, please? 2 dy by dx. Great. All right, Noah, P, what's the derivative of x, please? All right, now here comes the tricky part. Austin, you're up. You can do it. So product, let's go through it. We'll go through it together. The derivative of x squared y cubed. Okay, so first you do the derivative of the first half times the second. So what's the derivative of x squared? There's 2x. So this is just going to be plus 2xy cubed. Okay, right? Then plus x squared times 3y squared. And every time you take the derivative of y, a dy by dx. Okay? All right, good. Michael, go ahead.
Why take the derivative of x but not y?
Right? No, we're taking the derivative of everything. Right? But the thing is, whenever you take the derivative of y, you just put an extra dy by dx in there. Why? Because don't. Okay, stop. This is my serious look. It's okay to joke, but not when I'm trying to explain something. Okay. So again, the whole idea is though, right? Because you're taking the derivative, it has to be compared to one variable. So it's going to be the rate of change of y compared to x. That's all that means. So whenever you take the derivative of y, you're just left with the dy over dx. That just means a little bit of change of y over a little bit of change of x. So it's you're still taking the derivative of everything, right? Like 3y cubed changes to 3y squared plus a little bit of a change. That's all we're saying. Okay, so you're still taking the derivative of x, you're still taking the derivative of y. It's just with the y there's the extra dy by dx. Everything else is the same. You weren't here yesterday, Brendan, were you? Does any of this make sense?
I'm just wondering why the x squared would be times the x squared by y.
Sorry, I didn't hear last one.
Just the second half of the equation.
Yeah, so what I just did is here, so you're okay with this or not really? Okay, so if you think here, this is just product rules I'm doing. Okay, so basically the way product rule works, it's like, it's f prime of x, g of x, plus f of x, g prime of x. Right, if your two things multiplied together, right? So the derivative of x squared is just 2x times y cubed plus x squared times the derivative of x squared. All right, so we're getting close to being done, but not quite. Okay, guys, stay with me here, please. Haley, I'd like you to be brave and tell me how to isolate or to solve for dy over dx.
So I brought the x squared over
Good.
here, and I put the 1 to the other side.
Very good, thank you. Whoops. All right, Emma, I'd like you to tell the class why she did that. Why is that going to help me solving for dy by dx? Excellent. So we're going to have dy over dx times 2 minus x squared 3y squared equals 2xy cubed minus 1. Now we're almost done. This is good, but not yet great. As I like to say. Last step, Alistair, is what? Good. So dy by dx is the rate of change of the slope of this equation. Would be 2xy cubed minus 1 all over 2 minus x squared 3y squared.
Would it be a bad habit if I wrote the bottom as 2 minus 3x squared y squared?
No, that's fine. Yeah, that's okay. Probably I should have done that. Probably should have done that. So Chris said he wrote it as 2 minus 3x squared y squared. That works too. It probably is easier to see. I just left it like that. Okay, can everyone close their eyes and put their heads in their desks for a second? You're really doing it this time, or at least closing your eyes if you think the desks are too gross, okay? You too, Teresa, thank you. Michael, please just close your eyes for a second. Just close your eyes. Just close your eyes for a second. Please raise your hand if you're feeling 100% confident in what we've done so far. Please raise your hand if you're feeling sort of confident but could use some more practice. Please raise your hand if you're feeling completely awful what just happened. Okay. All right, you can, it's okay, we can do this. Heads up, please, okay?
So majority on
Here's
one.
what- I kept telling you, this is anonymous. Yes, go ahead. No, it's not. That you could, but in this case, because it's not just like a simple term over a simple term. But yes, if this was like 2xy and the -1 wasn't there and the 2 wasn't there, then yeah, you could definitely cross out x's and y's like that. Okay, right? But in this one, it's too complicated, so we're not going to do that. Just so I am going to tell the class, most people are in the, I feel like I need more practice, which is good. That just means you're learning. Okay, that's where most people are at. Okay, so we're going to have lots more practice. Don't worry. Okay, I'm going to do one with the quotient rule right now. Okay, so example 2. I'm going to say x plus y equals 3y squared over 4 plus x squared. Okay? Now I'm going to hit pause in this video. Now the only thing to remember, okay guys, the only thing for the people that raise their hands saying they don't have any idea what just happened, the only thing to remember is every time you take the derivative of y, throw a dy by dx beside it. Right? That's the only new thing to these derivatives. Okay, everything else is the same. Okay, so that looks scary. Don't worry, it's not. Okay, the derivative of x you can do. The derivative of y is just dy by dx, right? It's going to be that 3y squared. You have to think for a chain, and we'll come to that in a second, okay? So you guys can do this, okay? Here's going to be tricky now, James. I was just going to ask what the derivative of x was, but now I'm going to have to make it worse now, okay? What's the derivative of x, James, please? 1, good. What's the derivative of y, please? Thank you. Are you ready to keep going? Okay. So if you remember how quotient rule works, right? It's the derivative of the numerator times the denominator. So what's the derivative of 3y squared?
6y and then letter here.
Lovely. Okay, good. Keep going.
Minus 2x and 3y squared.
Good.
That's over 4 plus x squared.
You know what, James? You put yourself down in this class and you say you know with confidence. Have confidence. That's wonderful derivatives that you just did there. That's wonderful. Okay? All right. For everyone else, it's not James. Okay? How are we feeling about this? Yeah, go ahead.
Okay, so why did you have to put the dy over dx at the end?
Because this is the derivative of x is all you're taking out here. You know what I mean? You're not taking the derivative of y in the second part, just the derivative of x. Now, there's a few ways we can, I can't talk, okay? Just assume that I can't talk, okay? And we'll continue with our lives, all right? What are some ways we can solve for this? There's a few different things we have to do here, okay, to solve. So is that a question or an answer? Go ahead.
Do you just like put the full, like the bottom derivative on the other side?
Yeah, I think that's what I'm going to try and do. Now,
That's the problem, isn't it?
it is a bit of a problem, but we can deal with it though. I'm going to run a room here.
Wait, what?
Just wait. Just wait.
Oh, he just gets stuff, right? I gotcha.
Whoa.
James.
4 plus x squared, is that right? Minus 2x times 3y, so I'm going to call that 6xy.
Oh, okay.
Now, you might say, Mr. Sally, what just happened there? That's probably squared here too, right? Yeah. Okay, so what did I actually just do there? Yeah, I expanded it too there, okay? Do you have a question without an answer?
Did you multiply like the denominators in both of them?
Yes, yes. Now, the reason I just skipped a step there was because I still need to isolate dy by dx, right? So I would have had to FOIL anyway, right? So I multiplied So going back here, where are we? I don't know where I am. Okay, so again, you're multiplying this, right, by both things to get rid of it, right, is what we did. Okay? Yeah, go ahead.
Could you put, like, expand the 6Y into, like, the bracket?
You could,
Because, like, that way you only have to isolate DY and DX after, when you start, like, shifting things over.
yeah, I don't know what I'm gonna do, to be honest. I'm just sort of flying by the seat of my pants right now because I don't have this in front of me, my lesson.
I tried something.
If that works, I'm gonna try and do this like what we do regularly, so I'm gonna do 4 plus x squared, dy by dx, minus 6y, 4 plus x squared, dy by dx, equals negative 6xy squared, plus 4 plus x squared. I think that's probably the easiest, something like that. Whoa, 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 whoa. Look at this. You guys are so quiet, and then I make one small mistake, and it's attack mode. Okay. It happens every year to me now. Okay, so we're looking sort of good here. I think. No, we're not.
Oh.
What did you just say? Oh, I thought you said your hair's not looking good. That's what I thought you just said. I was going to snap on you. I was going to snap. I was just about to lose it. You guys never seen me lose it, but I was just about to. But math gets me worked up here. Was that a question you had there before I started doing cells? You okay? Emma, you're good? Sorry, I thought you're
the type of person that would say that.
No, I thought you were going to say that. So sorry, internet, I would never use it on a student, but I almost did though.
Just laugh at her.
Now, what I just did here, guys, and I'm sure I can simplify the denominator there, okay? But this is like a level 10 or 9.5 difficulty derivative that I just did there. Okay, the simplifying is like a level 10.
And you can't do any more.
I could if I really wanted to. I could factor out a 4 plus x squared in the denominator.
You don't give us anything like this, will you?
No, like at this step, hold on guys. At this, can I talk please? Why is everyone here so rude to me today? This is ridiculous.
Rory's just mean to everyone.
Yes, I'm
He's a
just
bully.
Okay.
so mean. It's an
Can I
honor.
please continue?
Sorry.
Rory's baloney.
Okay, what I was trying to say was, if you get to this stage, and I would probably ask you, find the equation of the tangent at the point 2 comma 5 or something. So you can just sub in x is 2 and y is 5. The whole idea is though you have to isolate dy by dx. Right, that's the whole thing to get your slope. Alright, and then you can sub in the x and the y's to finish. Okay, who wants to cry right now? Raise your hand. Really, Nathan?
How about a nap?
I'm going to pause the video and then I'll give you one more example, okay? So you get a minute break here, is what you're going to get. Just to take a deep breath. Yes? Not always. Just because if everything's on the same side, there's no always rules for things. Okay, right? But just if things are on the one side and you bring them across, it's going to flip, right? So.